All right, class, this is Pre-Algebra lesson 12.1, basic geometric figures. So basic geometric figures. All right, so when you think of the word geometry, what comes to mind? And I tried to help you out with a picture of the earth right here. But the word geometry means earth measure. Earth measure. All right, and geometry basically has to do with shapes and figures and the relationships of shapes and figures. So it's the study of points, lines, planes, and the figures they form. Points, lines, planes, and the figures they form. All right, geometry. Study of earth, lines, planes, and the figures they form. So you start off with points. They're the basic building blocks of all figures, and they're identified by a capital letter. Capital letters. So you can see here we've got an example of point B. Normally, you'll see as we go along that they're going to be dots that are shown and capital letters are used to indicate them. But everything's made up of points, and I'll try to illustrate that as we go along. All right, points. Number three. A line is a set of continuous points that extend forever. All right, that extend forever. If we want to be more mathematical, we would say the word infinitely. Infinitely. In opposite directions. So that's the concept of a line, and we've got an illustration of one right here. So you can see this line here. It's located right here, and you can see we have arrowheads on both ends of the line, and those arrowheads are necessary because we want to illustrate that the line continues forever. So we can't draw it going forever, but it does extend forever. And so we use the arrowheads to illustrate that the line extends forever. How do you name a line? You name a line by naming, listen now, any 2 points on the line and using the line symbol. So for example, we can use the point B and the point X. They're both on the line with the line symbol over top. Or we could use the point B and the point B with the line symbol over top. Notice the line symbol also contains the arrows. Or, and look, there's a lot of ors. You can go PX if you want, all you military people, right? Any 2 points on the line with the line symbol over top. Now listen, no more than 2 points. Don't put 3 points, don't put 4. It's 2 points. Any 2 points. All right, my line symbol got a little bit further away from my TP there, but any 2 points form a line. So let's go back to A there. I should have filled that in already. Since any 2 points determine a line, the notation is 2 points on the line and line symbol. So you look at point T and you look at point P and you say, you know what? There is no line. Well, there's not a line shown. There's a line there. Oh, this keyboard's going to drive me crazy today. There's a line there, but it's just not shown. All right, my smart board is not being cooperative today. All right, not going to worry about it. So there's a line there. And remember, a line is a continuous set of points. You get a point, 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 point. Another point, another one, 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 another one. And there's just an infinite number of them in both directions. So though, even though a line wasn't shown, given any 2 points, there's always a line that goes between them. All right, so line TP. All right, even though it wasn't shown, whenever you have 2 points, then there exists a line that goes between them. All right, we are definitely having technical difficulties here. Let me see if I can get things going. All right, I hope. Okay, all right, let's continue on. All right, so the next shape that we're going to look at is a plane. A plane, not an airplane. A geometric plane is a flat two-dimensional surface. A flat two-dimensional surface. Usually I'll be holding up a piece of paper to illustrate that. Can't do that by video. But a plane is a flat two-dimensional surface that extends infinitely in all directions. Infinitely in all directions. Now, before I do the next thought here, let's look at the plane right here. We draw a border around a plane just to show where the plane is. But please understand, the plane extends forever that way, forever that way, forever that way, and forever that way. And if we had tried to draw it that way, you wouldn't see anything. So we use a boundary just to try to show that there's a plane there. Stuff in the plane, we put in the plane. Stuff not in the plane, we don't put in the plane. Okay? If I had to point out here, point B is not in the plane. That's why it's drawn outside of that parallelogram. All right? That's the concept and that's the idea and that's what we're dealing with. All right, so what's our question? To name a plane, you must give 3 points in the plane that do not lie along the same line in the plane. Did you catch that? There have to be 3 points in the plane and they cannot lie on the same line. So I can name this plane a bunch of different ways. I'll use the word plane and then I'll give those 3 points that are in the plane but are not along the same line. For example, point R, point V, and point S. Point R, point V, and point S are not along the same line, and therefore I can use that to illustrate the plane. Or, and again, there's numbers of different ways you can name this plane. STR, if you want it to. Again, it takes 3 points. Now, this is going to be hard to illustrate by video, but the reason you don't use 3 points along the line is there exists an infinite number of other planes that can go through those 3 points. And again, this one's hard to see, but it would go like this, right? You could have another plane going this way through those points. I mean, there's just an infinite number of them. And you know my artistic ability isn't great. So for those reasons, we do not use 3 points along the same line because there's an infinite number of planes that go through 3 points along the same line. All right, that may not have sunk in very well. It'll sink in more as you look at it more and as you get to geometry in high school. All right, number five, a line segment is a portion of a line. What portion? It's the 2 endpoints, and all points in between. It's the 2 endpoints and all points in between. That is a line segment. All right, so I've got one illustrated here along our line. So if you look right here, we've got 2 endpoints. We've got the endpoint of K and we have the endpoint of L. Now you use the endpoints to name the line segment. So give the 2 endpoints, the order does not matter, and then the line segment symbol is just a line over top. Some texts put dots on the end of each line, but normally it's just a line over top, no arrows, because again, the arrows mean it goes on forever. So look back at the illustration here again. So let me try to explain what the line segment is. The line segment is point K, and it's this point, this point, this one, this one, this one. If you notice, I'm turning the red line green. This one, 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 that one, that one, that one, that one. This one, this one, this one, this one, that one, that one, that one, this one, this one, this one, this one, that one, all the way to L. So it's point K, it's point L, and it's all these points in between point K and point L. That's a line segment. All right, let's go to our next page. All right, so the next shape to talk about is a ray. All right, not a stingray, not a devil ray. All right, we're talking about a ray, a geometric ray. What is array? Array is an or one endpoint and all other points in one direction. So it's an endpoint and all other points in one direction. So I have illustrated here along our blue line array. Point C is the endpoint. Go ahead and label that. Point C is the endpoint. And you can see that this red line extends forever kind of toward the left and a little down, right? And this line, this red line, really, this ray goes forever. Goes forever. Goes forever. Now, how do you name a ray? You must always name the endpoint first. C has to go first. The first point is always an endpoint. You use one other point on the ray. So we use the endpoint and one other point. I have two choices. I could call it ray CB, or I could call it ray CA. But we have to use the ray symbol, and the ray symbol looks just like a ray. It's the arrow on just one side. So notice point C is underneath the ray symbol, underneath the beginning point, the end point, and then it goes in the B direction. The second one, same ray, starts at point C and goes in the A direction. Well, the A direction and the B direction are the same direction. Starts at point C and goes forever in the A direction. Now, I could make up another separate ray if I wanted to. How about ray, don't do this because you'll muddy up your notes, but what if I had ray BA? That would start at point B and head forever in the A direction, right? How about this one? How about ray BC? That would start at point B and head forever in the C direction. Is ray AB the same, I'm sorry, is ray AC the same as ray BC? So again, I just did ray BC in purple, right? You see it there? Right here, going this way. That's ray BC. Starts at B, heads forever in the C direction. Is ray AC the same ray? And the answer is no, because ray AC is going to start there, goes in the same direction, but notice ray AC also contains those points where ray BC does not. And those are the kind of things that you'll have to try to understand and illustrate when we deal with rays and lines and line segments and points and planes and all of that. Okay? All right, next one should be something very familiar to everybody, and that's simply angles. Angles, A-N-G-L-E-S, are two rays with a common endpoint. They share, the two rays come together at a common endpoint. And you know what we commonly call the endpoint, that common endpoint where the two rays come together? See, if you look at the illustration down here, and again, don't do this on your notes to muddy them. You have a ray, for example, ray YX right here, and you put it together with ray YZ right there. And together, those two rays form an angle because they share that common endpoint of Y. Now, that common endpoint is commonly called the vertex of the angle, the vertex. How do you name an angle? All right, well, the standard way to name an angle is to use the angle symbol. Sometimes it looks just like that. It looks like an angle, right? Sometimes they put a little arc mark inside. Either way is okay. And then you have to name one point on one ray. So I'll use point X. The vertex must always be in the middle. And then a point along the other ray, the only one I have on that choice is a Z. But please note, the middle must always be the vertex, always, if you're going to name the ray. One point on one ray, the vertex, and another point on the other ray. Now, we do have a shorthand for angles. And the shorthand would be the angle symbol and the vertex. So I could just say angle Y. That's a little bit easier. It's a shorthand. The problem is you can't always use it. So if you look at our next illustration here, she says, where is angle T? Where is angle T? Well, here's a vertex right there. But we have no assurance of what angle is being talked about when they say angle T. Hey, is it this big angle? Doesn't this big angle have T as a vertex? It does. It does. So maybe they're talking about that angle T. Or is it this angle T? Doesn't that angle have T as a vertex? Oh, yes, it does. So maybe they're talking about that angle. Or how about maybe this angle? Is that angle T? Well, see, I don't know. Whenever there's more than one possibility or more than one angle sharing the same vertex, you cannot use the shorthand. So go ahead and put that in your notes. No shorthand for angle T. Can't use it there because we have no assurance exactly what angle we're talking about. In the first example, there's only one angle that has Y as a vertex, and we were fine using it there. Okay, you see the difference? All right, and remember, by the way, by video, pause at any time that you need to. You might need to do that here coming up as we're going to deal with some angles. All right, hopefully I reminded you to have your protractor ready with you. And so we're going to use the protractor right now to measure angles. If you remember, you got to take your protractor. First thing you got to do is you got to move your protractor and you got to get it in the exact right position. Okay, for this protractor, I've got to take the intersection of my lines and get it right on the vertex. Not only that, but I also have to get, let me move it up a bit. Whoa, that's not what we want. All right, I also have to get this line right here to line up with the ray of the angle. Okay, so that's what I'm going after. So again, whoops, don't want to shrink it, just want to move it. Let's get it right there at the vertex, right along there. Okay, now you have two scales. How do you read the two scales? So remember, I'm starting right here. This is my start. Therefore, I've got to start at the 0. All right, come on, stop doing that. Protract. I'm starting at 0. I'm reading the inside scale. So I'm reading this way. Oh, it's going to be a pain. Give me my red. So I'll have to start out here. So I'm going like this, and I'm reading all the way over to this ray. See how I'm following the numbers? So 10, 20, 30, 40, 80, 90, 100, all the way over to here. So I know I'm past 140. I've got to go up to this part to count how far past 140. 141, 142, 143, 144. All right, what's the measure of this angle? It's 144 degrees. All right, I'm going to leave all those marks there for time's sake. You guys can clean yours up. But you want to come inside the angle and put 144 degrees. All right, if you want to try to measure the next one by yourself, go ahead and pause the video and do that. All right, and if you've unpaused now, again, I'll show you how I'm going to do that. Let me shrink this a little bit. Okay, I need to get lined up. Going to put that on the vertex, and now I need to spin it to line up. Okay, that looks good. And now I need to read my scale. So 10, 20, 30, 40, 50, 70. This line right here is 70. 75 looks like 76 degrees. All right, so that is a 76-degree angle. All right, my protractor is odd because that looks bigger than 76, but that is what it's reading. Okay, so 76. And by the way, I can take my protractor. I can do it this way too and use the other scale. That's why you have that other scale. So I've got to get it lined up just right. There we go. Now my 0, oh, this is so much easier when you do it on an overhead. Now the 0 is right here. And again, I'm going around and you can see that that's 76 degrees. All right. So we have a 76-degree angle, and I'm going to come in here and label 76 degrees. All right, you should be able to make angles, or I'm sorry, to read the value of angles. Next page, we're going to make some angles. So I've got my protractor. I've got a straight edge as well. All right, you can see I gave you a dotted line on your paper. So take a straight edge. You can use your protractor. I can't because mine doesn't work as a straight edge and my ruler does. Take that, go ahead and put it right there on your line. I'm going to just take and make an endpoint vertex, and I'm just going to draw along my line. All right, move my ruler away, and you got something like that. So again, here's my endpoint right here, and now I'm going to make a 70-degree angle. So I've got to bring my protractor over. I'm going to line it up, and then remember, I'm reading the inside scale to where it's 70, okay? And usually you put a mark up above. Now with this protractor doesn't let me get real close, otherwise I would have. The mark goes there. I'll move my protractor out of the way. Now you guys would take your ruler. I can't do this here because it's a pain to line it up. But you would take your ruler, you would go through that point down to the vertex with your ruler. And again, we'll label it a 70-degree angle. All right, 135-degree angle. That's an acute angle. I'm sorry, an obtuse angle. And we're going to start the same way. I'm going to take my ruler. I'll come over here. I'll do this one in green. And again, I'm just going to give myself a starting ray. Move that away. Go ahead and make my vertex obvious. Move my protractor in. And let's get lined up. Come on, protractor. All right, basically like that. And now I have to read again. I'm starting at 0, and I'm reading around this direction, right? So 0, 90, and I got to go all the way to 135. So right here is 130, and I go 5 more, which is right there, 135. Again, not easy to do electronically, but that's the concept. So again, I'm going to line up that mark. I'll use a straight edge if I'm at home. I love it. But for here, I've got to just draw it. Otherwise, I'm forever trying to line up that ruler. Okay? And this is a 135-degree angle. Oh, and one more thing. Angles go on forever, so let's make sure we put our arrowheads at the end of each of our lines. All right? At the end of each of our rays. All right, constructing angles. Hopefully you can do it. Constructing angles. Let's go on. Let's talk about types of angles. What do you call an angle? Electronics, don't you love it? What do you call an angle that is less than 90 degrees? So it's called an acute angle. Us Italians, we think, hey, she's acute. She's an acute angle. She's less than 90. What do we call an angle that is 90 degrees? Well, we all know that. It's a right angle. And you guys should know the right angle symbol. So a right angle looks like that. And the right angle symbol is a little box where the right angle is. Right? That's a 90-degree angle called a right angle. What do you call an angle that's bigger than 90? Oh, grande. Well, she's not acute. She's obtuse. An obtuse angle greater than 90. So if you look up above, our first angle that we constructed was less than 90. That was an acute angle. The second angle that we constructed was more than 90. That was an obtuse angle. All right, and there's also such thing as a straight angle. A straight angle. And a straight angle looks just like a line with a vertex somewhere. Okay, along it, it's a straight angle. It equals 180 degrees. 180 degrees. All right, let's look at I. All right, notice a couple things about I. So here you use your protractor, you measured a few angles, but notice the directions here. Do not use a protractor. We want to figure out mathematically the value of angle ABC. So the first thing you have to understand is, where is angle ABC? I'm going to take my black and I'm going to trace out angle ABC, and you should do that as well. Here's as A along the one ray, a vertex of B, and C along the other ray. That's angle ABC, right? So we want this amount right here. By the way, is that going to be an acute angle or an obtuse angle? And I hope you're thinking she's acute. All right, how are we going to figure this out? Well, here's the concept. Notice this 110. The whole angle is 110 degrees. If we can subtract this angle, this one right here, from the whole 110, our angle ABC will be what's left. So that's what we need to do. We need to subtract it. So what angle is that? That angle there with the red arrow here is angle DBA. And when we're done, it will equal angle, and I should be putting little m's here for the measure of the angle, or how many degrees it is, the measure of angle ABC. Okay, so we got 110 minus, so how many degrees is angle DBA? How many degrees is this red angle right here? How many degrees? And hopefully you notice the right angle symbol, and therefore you say, oh, that's 90 degrees. And that's going to equal the measure of angle ABC. And so now we can clearly see that 20 degrees is the measure of angle ABC. All right, 20 degrees. That wasn't hard. And you'll have multiple types of problems like that. That's the logic. This is the work, okay? That's the logic. That's the work. Be orderly in your work. Be orderly in your work. All right, and I think that's our lesson for today. All right, so let me go back real quick and recap for you. All right, remember, geometry means earth measure. It's a study of points, lines, planes, and the figures they form. What's a point? Basic building blocks of all figures. Look, every figure we did, whether it's a line, a plane, an angle, a ray, it's made up of a bunch of points together, and they make everything. Remember, any 2 points determine a line. There's your line symbol. Be careful now. Geometry is a precise discipline. Got to use capital letters. You got to use the right symbol. Plane, you got to use the word plane, and 3 points not on the same line that are in the plane. 3 points not on the same line that are in the plane. All right, be careful there. Line segment, what's that? 2 endpoints and all the points in between, right? 2 endpoints and all the points in between. What do we talk about next? Array. Array has 1 endpoint and all points in a direction. Notice again the notation. The first letter has to be the endpoint. The other letter gives the direction. The second letter gives the direction. That's the same ray because they both start at point C and head in the A or B direction, which is the same direction. How do you get an angle? Put 2 rays together with a common endpoint. What's that common endpoint called? A vertex. How do you name an angle? Angle symbol, 1 point on one ray, the vertex always in the middle, 1 point along the other ray. Can you use the shorthand? Yes, if there's only 1 angle with that vertex. If there's more than 1 angle with that vertex, you cannot. All right, hopefully you were able to measure angles with your protractor, and hopefully you were able to produce angles with your protractor. Make sure we know acute, right, obtuse, straight. And then problems like this, you'll see this is highly testable material, both on quizzes and tests. All right, that's the lesson. Have a great night.